Okay, nomenclature dealing with acids. Acids donate hydrogen ions, H plus ions, aka otherwise known as acidic hydrogen ions or protons, not to be confused with the protons that you find in a nucleus. All acids contain at least one acidic hydrogen, and usually it's written at the beginning of the formula, but they must all have an AQ subscript. Organic acids, carbon-based acids, may be written a little differently. Their acidic hydrogens may be written at the end, but it will always have a distinct group of atoms ahead of it, like a COOH or a CO2H. Often, these are written with an H out front. An example of this is acetic acid. So sometimes the formula is written like that. This is also called ethanoic acid, or it could be CH3COOH, has to have an AQ, or HC2H3O2 with an AQ. So sometimes these are all the same compounds, just sometimes the H is at the back, or it can be put up at the front, just like regular acids are. Now, this CO2H is a specific functional group for organic acids, and basically it looks like that, and that H here is the one that's acidic and pops off. If the compound has an H out front but no AQ, then it's just a covalent compound. So if you see HCl, that is hydrogen chloride or hydrogen monochloride. If you see HCl AQ, then it's an acid. Then it's hydrochloric acid. So no AQ, no acid. First group we're going to look at are binary acids. Binary means two. So these acids contain a hydrogen and one other element and the AQ subscript. Their names start with hydro, end with ic acid, and the other element that's in the structure, in the formula, goes in the middle and it's slightly modified. So HBr is hydrobromic acid. So you take the INE off of the halogens and what's left, you add the ic acid. And H2SE AQ would be hydroselenic acid. Without the AQ, these are simply covalent molecules. Oxyacids. Oxyacids contain at least one H and a polyatomic ion containing oxygen and the AQ subscript. Names depend on the name of the polyatomic ion, the PAI. So if the polyatomic ion ends in 8, then they become ic acids. If the polyatomic ion ends in ite, then they become us acids. And the first part of the name depends on the other element with the polyatomic ion. So N is nit. You take off the ogen. Phosphorus, you take off the us at the end. Sulfur stays the same. And then the same thing happens for the halogens. You drop the INE at the end. So you really have to pay attention to your polyatomic ion here. So the first one, HNO3AQ. We know this is an acid because it has an H and an AQ. So we look at the NO3 for the polyatomic ion, and that is the nitrate ion. So this is going to be called nitric acid. The next example contains sulfate, SO4. So this becomes sulfuric acid. So you take the first part of the first element in the polyatomic ion and you add ic acid. Now, the next example shows the nitrite ion. There's one less oxygen. So this becomes nitrous acid. So if you've got an ite polyatomic ion, it becomes an us acid. Then the next example has sulfite. So this becomes sulfurous. Spelled that wrong. Sulfurous acid. So you have to pay attention. You need your polyatomic ion table. You need to pay attention to the polyatomic ion in there. If it's 8, it becomes an ic acid. And if it's ite, it becomes an us acid. Now it gets a little more tricky with the halogens because they have the per-8 ion and the hypoite ion. But the 8 and the ite kind of help you with this. So these become per-ic acid from the per-8 ion and hypo-us acid from the hypoite polyatomic ion. So HClO4, ClO4 is the perchlorate ion. So this becomes perchloric acid. HClO comes from the hypoite polyatomic ion. So this becomes hypochlorous acid. So the per and the hypo all have to do with the halogens. You're not going to do it for the nitrates, the sulfates, the phosphates, the acetates, okay? Just for the ones that contain the halogen with oxygen in a polyatomic ion. So organic acids, just to reiterate, these have special names depending on the number of carbons in the compound. The one you'll become familiar with this year is ethanoic acid, which is more commonly known as acetic acid. This is the vinegar in ketchup. And if you put vinegar on your French fries, this is acetic acid. It can be written as CH3COOH or HC2H3O2 or CH3CO2H, all with an AQ. It contains one acidic hydrogen, and if that is removed, we end up with a polyatomic acetate ion left over. And that's C2H3O2, 1 negative. All right, writing formulas for acids. This is a little more straightforward. To write the formulas for acids, you have to pay attention to the name to see if it's binary or an oxyacid. Add enough hydrogens at the front to match the charge on the anion, and then follow up with an AQ subscript. So, hydrobromic acid. So the clue here is that we have hydro. So hydro means there's only two elements. So it's hydrogen, and then bromic means bromine, and then an AQ. Hydrogen has a charge of +1, bromine has a charge of -1. Add them together and you get HBr. Nitric acid. So this contains the NO3 ion because it's nitric. There's no hydro, so I know it's not H and an N. So nitric acid contains the nitrate. The charge is 1 minus, so I need 1 hydrogen and an AQ. Hydrocyanic acid. So this contains the cyanide ion. And it's got 3 stars about it just because it's a little bit different for the naming rules. Hydrocyanic acid, it follows the rules of the binary acids because it also ends in IDE, like hydrobromide. So it follows those rules rather than the polyatomic ion rules. So hydrocyanic acid, I would need 1 hydrogen because I've got 1 negative charge and I need an AQ. Sulfurous acid. This is an oxyacid. It contains the sulfite ion because it's an us acid, which means I need 2 H's because it's 2 negative, SO3, and an AQ. Phosphoric acid. This is an ic acid, so it must contain phosphate, the polyatomic ion phosphate. So this has a 3 negative charge, so I need 3 hydrogens. Perchloric acid, perchloric. So this must mean I have the perchlorate ion, ClO4 1 negative. And because I have 1 negative, I only need 1 H. And I need an AQ. So the reason you need the same number of hydrogens as the charge is because the hydrogens each have a plus charge. So if the total negative is 3 negative, I need a total of 3 positive charges to make it neutral. So take the number of the charge for your polyatomic ion and add the same number of H's to make it neutral. I've included here a flow chart to kind of help you with the naming. So you got to ask yourself first, does the formula contain an H and an AQ? If the answer is no, then it's just a covalent compound and you name accordingly. If the answer is yes, you have to ask yourself, does the formula contain only 2 elements? If the answer is yes, then it's a binary acid and you name it hydro something ic acid. If the answer was no, there's more than 2 elements, there's hydrogen, oxygen, and 1 other element, then you're dealing with an oxyacid or cyanic acid. So you have to identify the polyatomic ion that's in it. So once you identify the polyatomic ion, you follow the rules. If it's 8, it becomes an ic acid. Per 8, it becomes a per-ic acid. Ite, it becomes us. And hypoite, it becomes hypoous acid. So hopefully this flowchart will help you cement the idea about naming acids.